All right, a question like this is a very popular SAT question, and you're usually given a graph. Sometimes you're not. But it says something like, what's the solution to 2x plus 6 equals 0? And you're absolutely welcome to solve this, right? You know how to solve this by subtracting 6, etc. You know what I'm talking about. But how would you solve this by looking at the graph? Because this can sometimes be way more complicated, and the solution is way easier when you look at the graph here. Well, what is this really saying? Well, we can think of this as saying 2x plus 6 is equal to y, and you're letting your y equal 0. So you're basically asking, what is x when y is 0? What is x? What is x when y equals 0? That's what you're saying. What is this x value when your y is 0? Well, where on this graph is the y 0? Well, this is x comma y, x comma y. Well, here is where y is 0. So you're basically saying, what is x when y is 0? So here your x is going to be equal to -3. What is the takeaway for this slide? The takeaway is that the solution is the x-intercept. X-intercept is where it crosses the x-axis. That is your takeaway. Okay, here's the $100 question. And I'd give you $100 to solve this. What's the solution to this? Basically, you're trying to find the x value that when you plug into x, you get 0. Well, let's go ahead and let's look at the graph. When you look at the graph, you can see that there's absolutely no x value that when you plug in that x value, you get a y value of 0. And that's because there's no x-intercepts. Therefore, there's no solution. So it's impossible to find an x value or a real x value that goes in there, and then when you solve that, you get 0. That's impossible. The reason why is there's no x-intercepts. How about this one? What's the solution to this one? Well, remember, we know how to graph this. This is standard form. And so if you forgot how to do that, you might want to watch the standard form video. But let me show you what that looks like right there. So what's the solution to this equation, this quadratic equation? Well, your answer is going to be x equals 1 and x equals 4. And you can check that if you want, right? You could go in, you could say 1 squared minus 5 times 1 plus 4. Well, that is going to give me 1 minus 5, which is -4, plus 4, which is 0. And you could try with 4 as well, and you'll see it does work. So these would be your answers, and you found them by looking at your x-intercepts. Here they are, your x-intercepts. So here's kind of a summary. When we talk about solving these equations, we want to find the value of x when y equals 0. These values, where the graph crosses the x-axis, are called the x-intercepts. Now, here's something I want you to write down, some vocabulary. These values are also referred to as solutions, zeros, or roots. Okay, so for the most part, I think I'll call them zeros or roots. Sometimes I say, hey, this is our solution. They're the same exact thing, just 3 different ways to say it. How many solutions can we have? Well, we already found that there's a way to have no solutions, and that's when it doesn't cross the x-axis right here. So that would be no solutions. One solution would be when it does touch the x-axis, but it does so only at one point. For example, here would be the solution x equals 3, because it hits here at 3. And then the last solution is the most common, and this is when you have 2 solutions because it's crossing 2 places on the x-axis. In this case, you'd have an answer of x equals -2 and x equals 2. So those are the 3 possibilities. All right, here's my example, x squared minus 4. What are the solutions here? We'll look at the graph. What are you thinking? If you said -2 and 2, you are correct. And think about it. Plug in -2 squared is 4 minus 4 is 0. What about plugging in 2? 2 squared is 4 minus 4 is 0. Okay, now you can try this one. What about 2x minus x squared is equal to 0? What's our solution? Well, if you said 0 and 2, you are correct. All right, now you might be thinking that there are other ways to solve this by just looking at the graph, and you're absolutely correct, but this is one of the methods. Thanks for watching.